Hello, welcome to our semiconductor education program. I'm Vincent Chang. Starting this lecture series, we're gonna investigate a special issue of differential amplifier. So I have prepared 3 lectures to explain the offset voltage issue of the differential amplifier. The first part is the concept. The second lecture is gonna be focused on bipolar input offset voltage. And the third one, we're going to talk about MOS differential amplifiers input offset voltage issue. Input offset voltage of differential amplifier concepts. First of all, allow me to assume you already have some concept of input offset voltage learning from operational amplifier, but still, so allow me to give you a quick review. On the left side, assuming it's an operational amplifier, if you tie the 2 input terminal, inverting and non-inverting of the op-amp together and pull down to the DC ground, in reality, ideally, no output voltage, but in reality, the real op-amp, a non-ideal op-amp, will happen an output DC offset voltage. VO here is the output DC offset voltage. The right-hand side is the model. Here's the model. You imagine the real op-amp, the non-ideal op-amp, is composed of 2 parts. Inside the op-amp, there's the op-amp. It's the ideal op-amp. An ideal, inside the non-ideal, there's the ideal op-amp with a source. That source is defined as the input offset voltage. That differential source, the DC source is the input, is defined as the input offset voltage. And they also go further. Think about the original output, VO, is generated by the differential DC input, which is the input offset voltage, and multiply by the differential gain, and generate that output. In other words, V offset times differential gain equals the original DC output offset voltage. Pay attention to the subscript. The numerator is O, DC output. The one in the denominator is 0. What does that mean by 0? A0. What is the A0? 0 means frequency equals 0, means the DC gain. Low frequency DC gain is the DC gain. Therefore, allow me to move on to the alternative viewpoint. Now you get the first viewpoint, the second viewpoint, alternative viewpoint. Let's apply a voltage. Let's go back to the previous one. In the previous one, you have the output DC of the voltage because the input terminal is grounded. So now when you apply a voltage, then the output will change, right? In what direction? If you apply a voltage, look at the right-hand side, because it kind of against the internal source. The external kind of against the internal. Look at the right-hand side, okay? The applied blue kind of against the internal orange. Then the VO will go down. And down to a degree that if the external cancel out the internal, the same magnitude but different phase, different sign, all right? And then the output will down to 0. So the second definition of the input of the voltage is you apply a voltage, then cancel out the internal so that the output becomes 0. The output DC becomes 0. That input voltage is defined as the input offset voltage. Look at the right-hand side. The first definition is more from internal perspective, the orange perspective. The second definition is more from external perspective, all right? The blue perspective. But here comes the differential amplifier. For the differential amplifier, let's say if the offset voltage is created is because of the issue, the reason why we have offset voltage issue is because of the mismatch. The mismatch, let's say load mismatch. Then the question is, how do you calculate the input offset voltage of this differential amplifier? So how to formulate the input offset voltage for differential amplifier? I'll give you 1 minute to think about this before we move on. What's my question? When you face the differential amplifier, assuming you already learned from the operation amplifier, then how to formulate the input offset voltage for this differential amplifier? Let's pause for 1 minute. The question I just raised is a good test to ensure you really grasp the concept. You really know how to deal with this issue. So how to formulate the input offset voltage of the differential amplifier? Number one, grounded. The input terminal should be connected to the DC grounded. Grounded. And then what? Then see the formula. So grounded, number one. And then grasp at this condition, what is the output DC offset voltage? And then what? Then plug in the formula. The output DC offset voltage divided by the differential gain will give you the answer for the input offset voltage. Input offset voltage of the differential amplifier. An alternative perspective. The external perspective tells us from the lesson we learned from operation amplifier is this. When you apply external, so that VO, and you watch the VO, when the VO go down to 0, the external is the input offset voltage. Same thing with differential amplifier. When you apply, the reason I put the cathode on the top, the anode on the bottom, is because I know this terminal is non-inverting. So when you apply an external voltage so that the output offset voltage becomes 0, then the external apply is defined as the input offset voltage. So this lecture is only focused on the concept to make sure you grasp the concept, know how to calculate, how to start, where to start, and what's the key step. Here's the takeaway. When it comes to the input offset voltage of the differential amplifier, what are the key steps? Number one, grounded. Make sure the input terminal is connected to DC ground. And then try to find out, number two, the step two. At this condition, for this differential amplifier, in this situation, what is the output DC offset voltage? The second step. And third step is to plug in the formula. Third step is to find out the differential gain and plug into the formula. So 3 steps: ground, input ground, and DC output, and then differential gain. All right? You may want to write this down on your note. 3 steps: input grounded, and DC output offset voltage, output, not input, DC output, and then differential gain. Plug into this formula. We'll give you the answer. Make sure you got this right. And then we're going to move on to solve an input offset voltage of the BJT differential amplifier with different kind of mismatch condition in the next lecture video. Thanks for watching.